Have you ever stopped to think, space itself, the thing everything sits in, could actually be quantum? We usually imagine spacetime as this smooth fabric, stretched and curved by stars, planets and black holes, just like Einstein described in general relativity. But here's the weird question scientists are asking today. At what point does this fabric stop being smooth and start acting quantum? You see, general relativity and quantum mechanics are like two geniuses that refuse to get along. Relativity explains big things: galaxies, gravity, space-time. Quantum physics rules the tiny world of particles. But when you push the universe to its extremes, like the center of a black hole or the first moments after the Big Bang, both theories have to work together, and that's where they break down. So, what happens there? Physicists think spacetime might not be truly continuous. Zoom in close enough, smaller than a Planck length, that's about meters. And space could be made of discrete grains, or quantum units, like pixels, but for the universe itself. Imagine if space and time were built from tiny quantum bits, sometimes called spacetime foam. Down there, the smooth curves of Einstein's equations might dissolve into chaos, little bubbles of spacetime popping in and out of existence. Gravity itself could be a quantum force, carried by an as-yet undetected particle called the graviton. But here's the catch. We don't yet have the energy or technology to probe spacetime that deep. To actually see quantum spacetime, you'd need an experiment far more powerful than anything on Earth, something close to the scale of the Big Bang itself. Still, theories like loop quantum gravity and string theory are trying to connect these dots. They suggest that spacetime isn't a stage where physics happens, it is one of the actors. It can bend, twist, and maybe even be entangled, just like particles. So, when does spacetime become quantum? We don't know exactly. But somewhere, deep beneath the smoothness of the cosmos, reality itself might be made of tiny vibrating threads of energy, a hidden layer where space, time, and matter all blur into one quantum ocean. And maybe one day, when we finally understand that level of reality, we'll realize that space and time were never separate things, just illusions created by something even deeper. If that blew your mind, hit subscribe, because here at Make Science Easier, we break down the universe's hardest questions into ideas anyone can grasp.